Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama-Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
I'm Maddie. For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, thank you for that, Maddie. So where do you attend school and what grade are you in?
I attend school at Cesar Chavez, and I'm in sixth grade.
Yeah, sixth grade. Woo!
Oh, looks like he likes sixth grade. He
Sixth
teaches
grade is
sixth
fun.
grade.
Yes, very much. Have you gone to Camp Keep, or are you going?
Yes.
What was your favorite part?
That's hard. Everything.
Did you
All right,
like
good
the
answer.
food?
There we go.
Yes.
Yeah, see, I think
Food.
that's one of the
Food's
things. They
always
have some great
top-notch.
food
Good
over
food,
there.
yes.
But I think the school that went this week got rained out for yesterday, so they had to go today.
Yeah, Stockdale.
Because of the weather.
They couldn't make it. The buses said, "No, we're not gonna." It's not the most paved trail to get to Camp Keep for those of you that haven't been.
So, what kind of math are you doing in sixth grade?
We do percentages. We do.
You've been doing a lot of things.
Yeah, we do ratios.
There we go.
Yeah, we do a lot.
Is there anything that you think you need more help on?
No.
Okay, so everything's been going pretty smoothly, right? Yeah. All right, well then that's great because any types of problems I give you, you'll be all right with them today, right?
Yes.
Very good. That's the attitude I like to see right there. Well, how about if you help me out with the social media problem of the day? Are you ready for that?
Yes.
All right, let's take a look at it together. So up here it says, what does n equal in degrees? So we have some angles up there, and it says 43 degrees, and it also has an n, and then there's a square. Do you have any idea what any of that stuff means?
Yeah.
So go ahead and tell me what any of that means.
So, wait, I explain?
Yeah, explain it. Like, what do you know, and how does it help you find the answer?
So, it's a 90-degree angle because you can see that there's a box in the other side.
So on the left-hand
On
side
the left-hand
of
side, there's
the box,
it's 90
that's square.
degrees. Yes.
Okay.
So then you do 90 degrees minus 43
Okay.
is 47,
Okay.
which is the answer.
So you think n is 47?
Yes.
You feeling pretty good about that?
Yes.
Why do you think 90 is up there?
Because 90 is up there because some people would just look to the left and say, oh, that's a 90-degree angle.
Okay.
That must be the answer.
Good. And because it says, what does n equal?
Yeah.
Right? Why do you think 43 is up there?
43 is up there because some people will just look at it and say, it's 43 plus 43 equals 86.
Because they look pretty similar, right?
Yeah. It
And
looks
then
pretty
45, why do you think that's up there?
45, it's probably like just a choice.
Okay, and half of 90 is 45, right?
Yeah,
Because if you look
yeah,
at the other
that's
side, it looks like, oh, it might be half of 90. I know one side is 90, so the other
Yeah.
one looks about half.
Yeah.
But you did it pretty quickly, and you had the answer of 47.
Yes.
Because you said that if one side is 90, because you've got a straight angle along the bottom, right?
Supplementary angle, I might add, if
There
we
you
want
go.
to go higher academic math there.
Well, and complementary is what we're looking for now, right?
Yes.
Because they add up to 90 and the others add up to 180.
Yes.
You know all this vocabulary, right?
Yeah.
Yeah, I know you do. You sharp little, right. So let's see. So you've got D is 47. That's what you're going to go with?
Yes.
All right, let's take a look and see if indeed D is correct. All right, there you go. Nicely done.
Oh, you got to
Feeling
blow it
pretty
up,
good
Mike.
about that,
You
right?
got to blow it up. You got to.
Oh, come on, man.
Boom, there it is.
That's
All
all
right.
right. You know what? I think Sophia
forget
Sophia is going to want to see that. You ready to blow it up?
There
we
yeah.
go. All right. So, one other thing I just want to talk about is because you have been on the program before.
Yes.
And when was that?
A year ago.
That was a year ago, right? When you didn't know as much math then, right?
Yeah, I did.
You know a lot more though now, don't you?
She knew it. Don't worry about it.
Right?
Just a little bit more.
A little bit more. You haven't learned a lot more?
I already knew it.
Well, I
Oh,
think,
you knew it.
Well, I think that's what we're going to do today.
good.
We're going
Well,
to
you
push
know
the
what?
envelope
We're going to
today.
get you ready for 7th grade then.
Okay.
There you go. That's what I like to hear. Hey, we do have phone tutors available most Tuesdays and Wednesdays between 3:30 and 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right. Well, today for our Math in the News, we are fortunate enough to have Steve Miniard in studio with us today. How are you, Steve?
I'm doing well. How about yourself?
Nice to see you. Looking pretty sharp there this afternoon. Something going on?
Well, we do have a big event coming up in actually just about an hour, hour and a half.
Okay. And I think we got one of the flyers right here, right?
Yes, we do. So tonight is our 38th annual, if you can see that on the screen whenever it pops up.
Yeah, we'll move it up a little bit so that people can...
Yeah, this is
photo of
our
that.
38th annual. Well, we took a two-year intermission during the COVID years, but this is our 38th annual Music Makers event. It is for all 5 of our junior highs, their chorus, band, and orchestras from all of those junior highs. And this year, we now have the Whitley TK8, and so they're going to be
Oh, that's
joining
right,
us.
because they've got all
They
the way
have
through
8th
there,
graders now, yeah. So they're going to be joining us tonight. We're going to have about 750 musicians.
Well, I was
on
going to say,
stage.
because if you've got 5 different schools going and you've got band, orchestra, and chorus,
Correct.
that's a lot of kids.
That is a lot of kids.
So what is your role with the district as far as the music department?
So I'm the Visual and Performing Arts Administrator. I'm responsible for the staffing of our music teachers. I'm also responsible for making sure that they have all they need to educate our students, and then also to grow into the arts and drama, dance eventually.
Which is a pretty important part of a student's schooling, I would say.
Absolutely. It's
Right, because it used to be STEM, and now we like to do the STEAM, right? Get the
STEAM.
A for the arts in there, right?
Absolutely.
And we love having you guys come in all the time and talk to us about music and the different instruments and things like that and how it relates to math. So what were you doing before you became the administrator in the position you're in now?
Well, immediately before I was in this position, I was actually the vice principal at Tevis
Oh, we don't want to
Junior
hear
High.
about that. Let's hear about the music part and stuff
But
like that.
before that, I spent 20 years as both a high school and a junior high school band director.
Okay, so you've had a lot of experience. So when did you develop a love for music? Because you obviously had to be young, because you obviously majored on that and going to school and stuff like that. Was it? Because it seems like a lot of students get into band and stuff in 5th grade now.
Correct.
Now, was it the same where you grew up, or was it different, or did you take different lessons, start earlier or later?
So when I grew up, and I grew up out of state, we actually didn't start until 7th grade.
Okay.
But by 8th grade, I knew that this is what I wanted to do.
And what, was there a particular instrument, or just the whole doing this kind of thing is?
Right. So, well, I actually started out on the oboe, which is not a common instrument. It's a double reed instrument, kind of looks like a clarinet for those of you that may not know what it is. And then I actually switched over to play the tuba and the euphonium. And so then that got me into marching band, and just a lot of doors opened up, a lot of opportunities to travel, not even just in state, but out of state. And
Had a lot of competitions.
a lot
with
of
marching
lot of
bands.
competitions, a lot of interaction with students from other schools and other states, and so you just kind of get to cast a pretty wide net of people that have the same interest as you.
Well, I know we've got some videos, some footage of the students practicing and getting ready for the event. So let's take a look at this one. Tell us what's going on here.
Okay, so this looks like it was from last night, actually. And this is our orchestra, which will be performing tonight. And there are about 180 students involved in this right now. They were practicing last night at Thompson Junior High. And as you can see, there's one of our bass players. And
So is there an instrument that there's just a ton of kids playing this instrument?
we have a lot of violins this year.
Okay.
We have always a lot of the popular instruments like flute, clarinet, trumpet.
Is there anything that you guys feel like you wish more kids would take up an instrument of?
Well, being a tuba player myself, we would obviously love more tuba players, but in a lot of the lower instruments, the trombone, French horn, and some of those instruments, if you start playing those in high school and you become pretty proficient on it, there's a lot of scholarship money out there for those type of instruments. So, and it doesn't mean that you have to major in music. It's just you need to be willing to be in their bands and play in some of their ensembles, and they'll actually pay you money for playing your instrument.
Playing that instrument, right? So something a little less common.
Correct.
And I do believe we have one more video, and this one's got a little sound, so we'll just sit back and listen to this one. So that's probably going to sound really good tonight when you've got everybody together in the big auditorium and stuff and everything's going.
Right, absolutely. Tonight at 7 o'clock in the Mechanics Bank Arena, just not far from here.
All right, so what we'll do is we'll put the, there it is, there's the information for you right there. Tonight starts at 7 o'clock at the theater, and hopefully everybody has an opportunity to go check it out. I know there's going to be a lot of family out there, and
absolutely, yeah, and
kids from the past going back to see.
You know, I've seen some faces in the studio that have actually taken part of this exact event.
Oh, that's right. Yeah, because there are kids. So let's talk about who in the studio has taken part in this.
Hey, how you guys doing? Good dinner over there.
So there's Mickey right there. So Mickey was one of your students many moons ago.
It's been a minute. Yeah.
And
16. Let's just put it
been
out.
that long?
Since 16.
Oh,
yeah, and I think in marching band, didn't you have our producer also?
The producer, and I think we strapped some drums on her. We strapped some bells on her is what we did. Yeah.
Yeah. So that's Mackenzie, and I think camera 3 is going over there, right? Yeah, there she is.
Hey.
Hiding in the shadows, but there we go. So,
did I just hear cheers somewhere?
Yeah, there's somewhere.
Anyway, so Steve, thank you for coming in. I know you guys got a big night. We want to thank you for taking time to come visit us first.
Yeah, absolutely. And you know, if you can't make the event tonight, because I know it's kind of last minute, but we did pop up the program, and it has a QR code on it. And so if you can get that QR code off of your television, you'll at least be able to see the program that we're doing tonight and the list of all the songs, and you'll be able to see all the students that are involved. And that's what is going to be taking place tonight.
All right, great. Well, thank you once again. That is today's Math in the News. 636-4357 is that phone number. In studio from Cesar Chavez, we have Maddie, a 6th grade student. And Maddie is going to work on some of the problems that she brought with her today. And you are working on expressions. So, here's the first one.
Go ahead and grab yours.
2x plus 5x plus 4x.
All right, talk to me. What do we know? What do we notice? What do you want to do?
Okay, so I can add the 5x plus the 4x equals 9x
Okay.
plus the 2x, which would be 11x.
Now that's pretty fast. Now a lot of students at home might be sitting there wondering, you can't add x's. X means multiply. So what's different, and what do we call the x's? Like first off, what's the academic term for an x or a letter in a problem? And what allows you to add those together to get 11x?
So a number in
A letter.
like I mean
There you go.
a letter in an expression or any other math, it's called a variable.
Variable. Aha. Okay. Keep talking. Keep telling me more.
So I can add the 5x plus the 4x plus the 2x because the x, if there's a same letter
Okay.
with all of the numbers, I can add them together.
Ah.
So if it was just 5x plus 4x, that would be 9x, like I got right here.
So if we didn't have the x here, how
Like,
would that change your problem?
So then it would be 2 plus 9x.
Ah, okay, so it's important that they have the same variable.
Yes.
And do you remember in class any specific term your teacher used to describe when they have the same variable and exponent? Like, what's the actual name for that allows us to add these terms together? They are something terms.
It was.
You want a hint?
Yes, I need.
Starts with ul, rhymes with Ike.
Like terms.
Like terms, yeah. So
I
that
remember
is.
I was
yeah,
going
you
to say
got
a lot of kids use that word when they're stuck, or it seems part of their normal vocabulary. Like, you know what I'm talking about. I like this. And
I like terms that have the same variable and exponent. That's what I like. Those are my like terms.
You ready for the next problem?
Yes.
All right.
I got you.
Okay.
All right. So we have 5.
All right, 5.
Open parentheses.
Oh, here we go.
4x, close parentheses.
Close parentheses.
Is that it?
That's it.
All right. Talk to me.
So, draw an arrow. My teacher would say, draw the stinking arrows.
I love
Okay,
it.
because kids wouldn't draw the stinking arrows.
I love it.
So you do 5 times 4 equals 20. Then you can't forget the x, so you take it over here. 20x is your answer.
Bam. Now, I'm going to increase the difficulty. You are right, 20x. I'm going to throw a curveball in here. We're going to see what happens. You ready?
Yes.
All right. What if I put plus 3 in there with it?
Draw another arrow.
Oh, another stinking arrow. Okay.
So it'd be 5 times 3 equals 15. So it would have to be 20x.
It's all right, I'll take it.
20x plus 15.
Now, why can we not combine those?
We cannot combine them because the 15 does not have an x.
Ah, so they are not.
Like terms.
There we go. All right. How do
So
we do,
now
Mike?
that you did that, which
Yeah.
is beautiful, let's try one more of these.
All right. I got this piece.
So we have 7,
7.
Go for it.
Oh, okay.
open parentheses,
Oh, here we go.
2x plus 6y,
Ooh.
close parentheses.
What?
Perfect. Okay. So we can't combine these because they're not the same.
Okay.
So draw the stinking arrows.
The stinking arrows. I'm going to have to use that in class tomorrow.
So 7 times 2 is 14.
Okay.
Then 7 times 6 equals 42.
Sorry, when you heard that gasp, that was my teacher mode going, where are the variables? But I forgot you write them at the end. Okay,
Yeah,
keep going.
I write them at the end. So 14x plus 42y is your answer.
You
Looks
sure
good
it's
to me.
not 56xy?
Huh?
Could it be 56xy?
No.
Why not?
Oh, wait.
He's not saying you're right or wrong. He just is checking with you. Could it be or can it not be? Remember we talked about what is required
Oh, yeah. Okay.
in order to add them together.
I can't.
Why not?
Because they're not the same.
They're not.
They're not like terms.
There we
All
go.
right, good.
Now I'm going to throw a curveball into this. We're going to work backwards this time.
Backwards.
And you've
Yeah.
got a minute to do so.
Well, we'll only need 30 seconds because we have a pro in studio, Mike. Here we go. So if I give you this, 15x plus 20, I need you to give me something with a coefficient and something inside parentheses, meaning I need you to find the number that goes outside and what has to go inside to produce this expression. What are your thoughts?
You put a 5 because
Okay.
they're both multiples of 5.
I love it.
You can do plus.
All right.
You need an x in there. 3 times 5 is 15. Then you can do a 4 because 5 times 4 is 20.
Boom, 30 seconds. Told you so.
That was awesome right there.
All right.
Nicely done, young lady, because I know
Nice
that he was
work.
trying to get you going, and you were all over that problem, so nicely done. For doing a great problem like that, you've got yourself a pass to any sporting event at CSUB this season, so congratulations on that. I know that they've got basketball going, softball's coming up, baseball's coming up, so you've got a couple of different sports to go check out during the spring activities. And we'll be back with more right after this.
There's airplanes, and then there's airplanes. Stratolaunch's The Rock, aka the mothership, is considered the world's biggest airplane and had its 9th test flight here in Mojave. Hi, nice to meet you.
Nice to meet you too.
My name's Elise.
My name is Brandon Wood.
So can you tell me a little bit of something about you and what you do here at Stratolaunch?
I'm the Vice President for Programs and Operations at Stratolaunch, and I help ensure that we have our programs set up to be successful to grow our company here in Mojave.
And why is it here in Mojave that you guys are able to make these changes and have these advancements?
It goes back many, many years to the culture that I would attribute to Bert Rutan and the scaled composites culture that he created now 30 or 40 years ago in Mojave, in East Kern County, a can-do attitude of people that can rapidly design vehicles, unusual vehicles, and get them operational and make them fly. And so Stratolaunch is a result of that culture and capability unique to Mojave Air and Spaceport and unique to Kern County.
Stratolaunch manufactured one of the largest planes called The Rock, and it has been in flight the longest, remaining in air for over 6 hours. So will you tell me something a little bit about this massive mothership of your guys's?
Yes, it's certainly an unusual platform. 2 fuselages, a wingspan of 385 feet. It's we can walk below it here, which is unusual, of course, but it's got a tremendous capability to lift over 550,000 pounds of payload. So.
And what have you seen with the economic impact with the projects you have with the your guys' mothership and hypersonic?
For a plane this size, we do have a dedicated ground crew for it. Of course, we have a manufacturing operation here in Mojave as well. And so between our manufacturing, our production, and our operations in Mojave, we have a team of over 300 people at Stratolaunch. We also use a lot of the local services, machine shops, and other support functions for our manufacturing facility.
And what are some of the future projects you guys see for yourselves?
So we're right on the cusp of hypersonic operations with our Talon vehicles. And so we will continue to manufacture those vehicles here in Mojave. In addition, we have other vehicles, other ideas and concepts that we're developing to carry on our Rock carrier aircraft and to operate here in Mojave.
And now with all these future projects, how do you see that for the community here and the growth of it? And do you think you guys will employ more jobs because of the future? Absolutely,
yeah. We're growing as a company. We're growing quickly. We're over 300 people right now, and we expect to continue that growth and hire more skilled manufacturers, fabricators, systems mechanics, engineers in Mojave to ensure that we've got the key skill sets that we need.
So I'm excited to see what you guys do in the future and grow and what you guys bring to the community. And thank you for speaking with me today.
Yeah, thank you. Thank you for coming here.
All right, well, we've got Maddie, a 6th grade student from Chavez School, in studio with us today. And you did well with the expressions, and I know you guys started expanding and going a little bit further. But right now, I need you to help Mickey solve a problem that a student phoned in with, but they can't stay on the line with us right now. Okay, so you guys are going to solve it, and then they'll be able to watch it on YouTube later on. Okay? So it says 2,760 divided by 5. But instead of just doing it, it says, how would you do this using mental math?
Mental math? Okay. Let's see here.
So you may have a couple of different ideas.
What are your thoughts?
We'll try a few.
So, I can kind of do this in my head.
So when you say in your head, take me through the process. I know your brain is quickly running through to allow you to do this, because that is mental math.
Yes.
So what is your brain doing that gives you almost like a shortcut for this?
Would you like me to show you, or would you like go? What's
Talk
going
me
in my head?
through it, and I'll write it out.
Okay. So, I like to call it a doghouse
Okay.
when it's a line.
The square.
Yeah, the square.
Okay.
Or not the square, but like.
Why don't you draw it, since I'm
like
not
that?
familiar with
Like.
Oh, a division symbol.
2, 7,
Yes.
2, 7, 6, 0,
Okay.
5. Like, that's what I like to do.
Okay.
Or that's what I was taught to call it, doghouse.
Okay.
So I can tell that 5 times 5 is 25. And then you subtract that minus 27.
Okay. So what I'm going to do is I'm going to try something a little different here. So if I were to split this up by place value, 2,000, you agree that 2 is in the thousands place?
Yes.
7 is in the hundreds, so it's worth 760. Make sense so far?
Yeah, you
Okay.
could divide 2,000 by 400.
To make 5? So if I do 2,000 divided by 5, it would equal
400.
400. Because if I also, because some students may see 2,000 and think, oh my gosh, that's a really large number, that's too much. If I hide some zeros, how many times 5 to make 20? 5 times.
4.
And how many zeros did we cover?
2.
So we have 400.
Yes.
Now, 5 into 7, not enough, but what about 70?
70. That would be.
It's over
It's not.
10.
It's over 12.
Okay.
Because 5 times 12 is 60.
Which again, we're still doing mental math. We're just using
Yes.
what we know, so keep going.
So then 13 would be 65. 14 is 70.
There we go. So now it's 400 plus.
Plus 14. 140.
140, good.
140.
And 5 into 60?
12.
Aha, so there we go. We did some mental math. We kind of broke it down by place value. And now we have a couple pieces we can put together.
That would be 2. That would be 4 plus 1 is 5. 4. Oh, wait.
4 plus 1?
Oh, I didn't see the 1. 5.
552.
552.
I know there are many different ways to do this, Mike. What are your thoughts on another way that you are thinking about?
Well, that's a nice way to do it, but as she was writing it, we eliminated some of the mental math because she was writing it down.
Yes.
But I think what they want to do is they want to be able to show the student what you were doing without writing it, and in your head come up with 552.
All right. I
Does
think
that
I
make
have an
sense?
idea.
Yes.
I think I have an idea.
Oh. Is it like, it could be like when you like have to like write it out, like,
And I'm
Like
sure you
an
could write a couple of
explanation.
numbers, but they don't
Yeah.
want you doing the whole long division thing.
yes. So,
Talk to me. What you got?
5 times 5 is 25.
Okay.
I like to put an X.
I love it
or
because
a
5
0.
couldn't go into 2. Very good.
25 minus 27 minus 25 is 2.
So now we're dealing with 20.
6.
Okay.
So then you can do 5 times 5 again, because that's 25.
Okay.
Minus 1 is
So we had a little 26. We subtracted
I mean,
25.
25.
We have
1. And then you have a 0, which is 10. Then 5 times 2 is 10.
So that way
552.
you came about it a little bit quicker,
Yes.
right? So there's a couple of different ways, and I think that's helpful for the student that was watching, right? Because
Yes.
you can think, all right, 2,760, I can start with 2,000, right?
Yes.
Which you did the first time. But then you can think, all right, 27, what's close to 27 divisible by 5? That doesn't go over 5 times 5, right? So that's another way to do it. You feel pretty good about helping that student out?
Yes.
All right, there you go. Erase the board. I have a brand new challenge for you kids.
go for it. Mental math, or can we use
Oh,
some
no,
arithmetic?
We're done with the mental math.
All
We're
right,
gonna
all right,
write
here we
stuff
go.
down now. And we'll see how far you go, all right? So we're just going to start on this. So this one is up on the camera, so we'll take a look at this. So it's talking about consecutive numbers. So consecutive numbers, and it says 1, 2, 3, right?
Yes.
They're consecutive numbers. They go in an order and they go in row. 41, 42, 43, those are consecutive numbers. 1, 3, 5, 7 are not because they skip a number. Do you understand that?
Yes.
Okay? So if I go 2, 4, 6, are those consecutive numbers?
No.
No, because I'm skipping numbers in
Yes.
between. All right? So the example says 9 can be written as the sum, which means you have to add numbers,
Yes.
of consecutives. So if I go 4 plus 5, because those are consecutive numbers, they add up to 9.
Yes.
I can also do 2 plus 3 plus 4,
Yes.
and it adds up to 9.
Yeah.
Okay, so there's more than one way to get some numbers. All right? Then we can see 15. There's 3 different ways to do that. We can go 1 plus 2 plus 3 plus 4 plus 5. Or we can do 7 and 8. Or we can do 4 plus 5 plus 6.
Yes.
So do you understand how consecutive sums
Yes.
work? All right. So between 1 and 25,
20,
there are 5 numbers that you cannot do consecutive sums with. So I want you to see if you can figure out any of those numbers that do not work. Okay? So you and Mickey go ahead and start, and we'll see how far you guys get.
So what do you think? Do
Do
you
we
want to
have
go?
do we have to like make it like equal to 25?
So for example, let's say I pick 3.
3. Okay.
I can make 3 using consecutive numbers,
1, 2.
1 and 2.
Yes.
Correct? What about another number? Let's keep going from there. So we know 3 is good.
25.
Okay, you want to try 25?
Yes.
Okay. So what 3 numbers in a row do you want to add to see if they make 25?
Let's see here. 10, 11, and 12.
Okay, go for it. And what do we get?
That would be 20, 21 plus 12. 12 is 33.
That's not 25.
Oh, wait. Yeah, it's not.
So it
could
doesn't
we-
mean 25 can't be made, it just can't be made with those numbers.
Yes.
So do you want to try a couple different numbers to use?
Yes. Okay. So that's too big. So let's try 5, 6, 7.
Okay.
5 plus 6 is 11. Plus 7 equals 18.
So now we're low.
Too low.
So we were really not really high, but we were high. Now we're
Yeah.
low. So we were 5, 6, 7, 10, 11, 12. Let's kind of maybe we can work towards the middle, see if another combination works.
Maybe let's see here. 8, 9, 10.
Okay.
9 plus 10 is 19. Plus 8 is, well, I like to think of it 9 plus 8 because I always say, I take away 1, which is 7.
To
and
make
then
it
I add
20.
it, yeah, 20. And then plus 7 equals 27.
Ooh, we're getting close, but we're still a little high.
Very close. Let's see here.
So that was 8, 9, 10. We did 5, 6, 7. What are you thinking now?
7, 8, 9.
Give it a shot. Worst that happens is it doesn't work. We try something else.
That would be 17 plus 7. I like to cover the 1, which is 14 plus 10. The 1 is 10.
Gotcha.
Oh.
Multiply now. All right.
Equals 24.
Oh.
So close.
Now, one thing you've been doing is you've always been trying 3 numbers.
Yes.
Can you use more than 3?
Could we use less?
Because
than
remember when
3?
we did 15, we had
could
1
use
plus 2
less
plus 3
than
plus 4
3.
plus 5.
Oh, okay. That changes things.
All right. Bring it on.
Okay. So, I'm going to divide this by 2, which is 1, 0.
You're good. 2 times.
So it's like about 12. So
Okay.
we'll say like 10 plus 11. That's too small.
Okay.
So think about what you just did. I think Mickey
Yes.
sees it also what you just did, because that was a nice thinking that you were doing to divide it.
So if 12 is half, but is it really 12 or is it a little bigger than 12?
A little bit bigger.
So we know 12 is going to work,
Yes,
but
12
we're going to need something a little bigger.
plus 13.
Aha! We've
So-
struck gold.
Yes. 2 plus 3 is 5.
Love it.
1 plus 1 is 2, which is 25.
Aha! So 25 works. Only 24 other numbers to eliminate.
So that's good. So you found that 25 does work, so it's not
Yes.
one of the 5 numbers.
Yes.
Let's start at the other end, 1.
1.
Can you add any numbers to get to 1?
And remember, consecutive means you need at least 2 numbers in a row to add up to that number. So can you add 2 numbers from 1 to 25 to make 1?
0.
Zero's not
Point.
included.
Well,
between 1 and 25.
well, the numbers 1 through 25 when they are added. So let's see if she
So
does.
if I get 26, I can add a -1 onto that?
No, we're not doing negative numbers. They must be positive whole numbers. Now, 0. So here's what we're going to do. We're going to let you guys work on a couple of those right now, because what we're going to do is we're going to talk a little math
All right,
with
let's go back.
Pythagoras.
Hi, my name is Kaitlynn, and today I'm going to talk to you a little bit about the Pythagorean Theorem. So we're going to start by drawing a right triangle on the board, and we're going to use this little symbol to show that it's a 90-degree angle, making it a right triangle. We're going to label these two legs, they're called legs, A and B, and we're going to label the hypotenuse as C. So these letters are going to help us find the, what C is in the end. So the algorithm you would use to find it is a squared plus b squared is equal to c squared. So a squared is basically equivalent to a times a is equal to a squared. So let's try to find the hypotenuse on a triangle. So let's say that a is equal to 3 and b can be equal to 4. So you're going to do a times a, which is basically 3 times 3, and that is equal to 9. And then you have to do the same with b, so that would be 4 times 4, which is equal to 16. Now we know what a squared and b squared is. We could plug that into this equation, and that would be 9 plus 16. And 9 plus 16 would be 25. So in other words, c squared is equal to 25. So in order to figure out what just c is rather than c squared, you would have to find the square root of 25. And for this instance, the square root of 25 would be equal to 5. So in the end, that would mean that c would be equal to 5. That was a little bit about the Pythagorean Theorem.
Was
All right, there we go, learning a little bit more about the
can do a little more with
Pythagorean
6.
Theorem right there. Maddie is a 6th grade student from Chavez, working on consecutive sums right now. So we know that 2, you worked that out because there's no way to get 2.
Yeah,
You can't get 4,
Yeah, you can't get 4 either.
right? So
We got
you saw that you
5.
could get 3 because you could do 1 plus 2.
Yeah.
And how did you get 5?
2 plus 3.
2 plus 3. We see that 6 you can do
Yes.
because 1 plus 2 plus 3.
Yeah.
So now you're on the number 7.
7. That would be 3 plus 4.
Boom, there we go. Let's go to 8.
Because,
You got it.
yeah.
You said it out loud. 3 plus 4.
yeah.
So keep
8
trying, let's keep on
equals-
going.
8 equals, it could do like 3 plus, oh wait. So,
You're good. You're processing. Just tell me what you're processing.
1 plus 2 is 3, plus 3 is 6.
We're going to get too big, huh?
Yeah, we're gonna get too big.
Okay, so let's see if there's any other way we can make 8 before we try to put that as an option here that we can't make.
Yeah. So,
Can't do 4 plus 4 because that's the same number.
same number.
1, 2, 3, 4 didn't work. Because 1 through 4 makes 10.
2, 3, 4.
Okay, give it a shot.
2 plus 3.
Whoa, all right.
Plus 4 is too big. It's 9.
Okay, so that's out. Anything else?
Um,
What about 3, 4, 5?
3, 4, 5. No, it's too big.
Too big. So you want to go with 8?
Yeah.
Okay. 8. Be gone, 8. All right. Moving on to 9. What are your thoughts on 9?
Easy. 4 plus 5.
Bam. Easy
9.
it is. All right. 10.
10. We could do. We could do 2 plus 3 is 5, plus
4
4.
is.
9.
You only need 1 more. You only started at 2, so we could start at
1, 2,
1, 2,
3,
3, 4. Does that give us?
Wait, so
See what you
10, wait, equals 1 plus 2 plus 3 plus 4. That's 3 plus 3 is 6 plus 4 equals 10.
Boom, 10's good,
Perfect.
but it doesn't help us get an answer. So we'll keep going.
Yeah.
All right, 11 now.
11. We could do, let's see here. 2 plus 3 is 5. Plus 4 is 9.
Plus 5.
Plus 5
That's
is
big.
too big. So maybe 1, 2,
Remember, 1 through 4 is 10. If that helps you kind of a little bit, 1 through 4 will get you 10
1,
every time.
3, wait,
1, 2, 3, 4. We'll always add to 10.
yes. So, can't do it.
Well, here's a hint.
Oh,
Take
wait.
the next number
The next 6.
and the one before it.
Oh,
Ah,
I forgot about that.
you're good. So remember, we can always use 3 numbers. We can use
Yeah.
2. We can use 4.
Yeah.
And that's where some students will get caught up. They think it has to be 2. It has to be 3. It's however you work it as long as
what
they're
I was thinking.
consecutive. All right, so let's go on to 12 now.
12. That would be 5. Wait, 5 plus 7. Oh, no.
Oh, so, see, now we're getting caught up.
6 plus
Yeah.
7's too big.
Yep.
1, 2, 3 is 6.
Plus 4 is 10.
10 plus 5 is too big.
Okay.
So let's see.
What are you thinking? You think 12 is one of them?
Well, you had said 7 plus 5 is 12.
Yes.
So think about how you can make 7 and add it to 5.
Add it to 5. I mean, we would have to do like 5, 6, 7, but that's too. I mean,
Find numbers to make the 7 you need.
Oh, okay, okay. So we could do 2 plus. Wait. Wait. What? Wait.
I'll give you a hint.
Wait. Oh. 3 plus 4 plus 5 is 12.
Ooh, yeah. That is 5.
That looks like
I promise it's a 5.
It's a 5.
There you
Oh,
go,
that
all right.
looks like an S.
That's all right. We're getting there.
5.
But no, that works. So that
Yeah,
doesn't
that
help us.
works.
All right, going on to 13. What are your thoughts on 13?
My mind is blanking out.
No worries. It's after 5. It happens.
After 5. Okay. So
All right, 13. How do we get there?
13. We can do 7 plus 6. Oh,
Okay.
wait. Yeah, 6.
Yeah, okay.
6. So we
13's
could do 2.
You still going for 13?
Oh,
7 and 6 eliminated it because that made 13.
oh yeah.
So we can go on to 14 now.
14. 14. So that would be we could do.
So we can kind of go back to your strategy of dividing it in half, which is
Yes.
7, right?
7.
But
yeah.
it's
7.
directly 7, so we can't do 7 and 7, so we may need to go up a little
Yeah.
bit or down a little bit. What are you thinking?
Maybe down a little bit.
Okay, so 7 down to 6, and that's going to have to be 6 plus.
6 plus 8 is. Oh wait. No. But 6 plus 8 is 14. But we can like.
All right, so I'm going to let you guys keep working on number 14
We got
right
this.
now, right? Because you guys are more than halfway to 25, right?
Yep.
So you're more than halfway through. So you keep working on that. We're going to find out
14
what's going on this week at NASA.
A commercial resupply mission to the space station, preparing to make a delivery to the moon, and monitoring our changing Earth from space. A few of the stories to tell you about this week at NASA. On January 30th, a Northrop Grumman Cygnus cargo spacecraft launched to the International Space Station atop a SpaceX Falcon 9 rocket from Cape Canaveral Space Force Station. 2 days later, the Cygnus, loaded with 8,200 pounds of scientific investigations and cargo, safely arrived at the station. This is Northrop Grumman's 20th commercial resupply services mission to the space station for NASA. NASA partner Intuitive Machines will use the company's Nova-C lunar lander to carry a variety of NASA science and technology demonstrations to the Moon's South Pole region for the benefit of all. The IM-1 mission, which is part of our CLIPS initiative and Artemis campaign, is targeted for launch from our Kennedy Space Center during a multi-day launch window, which opens no earlier than mid-February. The NISAR Earth Observing Satellite mission is a joint effort between NASA and the Indian Space Research Organization that will deepen our understanding of deforestation, shrinking glaciers and sea ice loss, natural hazards, climate change, and other global vital signs. The satellite's advanced radar system will monitor motions of the planet's surface down to fractions of an inch, along with changes in other characteristics. NISAR is expected to launch from India in early 2024. NASA's 2024 spinoff publication features many commercialized technologies that use NASA research and development expertise to impact everyday lives. From squishy robots that can be sent into dangerous situations before first responders, to aircraft routing technology that enables increased fuel efficiency and smoother flights, to medical technologies for diagnosing illnesses like the coronavirus, hepatitis, and cancer. Learn more at spinoff.nasa.gov. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Does it have to start at the
All right, so you guys are continuing to work, and right now you're on 14.
Wait.
And you know that
we need to
1,
eliminate
2,
one.
3, 4, and 5 make 15.
Eliminate one.
Is it still consecutive? 2, 3, 4, 5? There we go. So now, all right, there we go. All right. So all that work just to say 14 is not in the answer.
Yeah, it's
All right,
not.
so now let's think about 15.
15.
Can we make
15 was on the paper.
Ah, yes, it was. 1, 2,
Yes.
3, 4,
So,
5 makes
yeah.
15. Okay,
So
16.
we don't can't do that.
Okay.
So 16. Wait. So 16 equals 2 plus 3 plus 4, 6, 10 plus. Oh wait.
I'll give you 9, not 10.
Oh wait. Yeah.
You're good. You're good. Keep going.
Plus 5 is 14. Can't do that. So
Okay.
1 plus 2 plus 3, that's 6, plus 4 is
1 through 4
10.
will always equal 10. Very good.
Plus 5 is 15.
So we need to get one bigger.
One bigger. So earlier I said 2, 3, 4, 5. Oh wait. What did I say earlier?
You're saying a lot of numbers. All right, so we know it's not 2, 3, 4, 5, not 1 through 5, because 1 through 5 is 15.
15.
2 and 3 is 5. 4 is 9. Plus 5 is 14. So we're off by 2.
And it can be bigger. So it could be. So we
7
know that
plus
half
8.
of that is 8.
Okay.
So we can't do 8. We can't do 8.
Right, because we can't do 8 plus 7.
Yeah,
We can't do 8 plus 6
yeah.
or 8 plus
So
9.
maybe we could do 6 plus 7. That would
13.
be 13. So we could do.
You guys may have run your course on this one.
You think 16? Can we make 16?
Yes.
No.
No, we can't.
I'm going to say no. Mike, are we confirmed 16 is not?
Let's go ahead and throw 16 up there right
I
now.
love it. There we go. That's
Yay!
the approval without
That's
approval.
why I couldn't do it.
All right.
That's
See,
why.
there we go.
That's
He's-
why.
he's just
That's
messing
why.
with
It's not a brain fart.
You're good. You got
That's
it.
why.
Cross that puppy out. We got 4
Get out
numbers.
of here.
17.
17. Okay. Let's see here.
And remember, it doesn't
7.
have to be 5 or 4 numbers. We can use it 2. We can use 3. As many as you need. Bigger than 1.
Yes.
So what can we add?
Think about the way you were doing it before by taking it and cutting it in half.
So what's
Yes.
close to half of 17?
So close to half is like 8 point something.
8.5.
8.5.
So
yeah.
8.
8.5. 8 plus
You don't have to guess.
You got to go above 8 or
next
below 8.
number
There's
has
only two
to be
options.
Above.
Okay,
Wait.
so above 8, you'd have to write down 8 plus.
9,
Okay. 8 plus 9 gives us what?
17.
Aha! All right, so we can still use 17. Let's go to 18 now.
18. So half of 18 is 9.
Okay.
We have to go lower because right on the dot.
Okay.
So we could try.
I don't know. Yeah, can't do 9 and 8. That's 17.
Yeah.
Can't do 9 and 10. That's 19.
Yeah, I can't do 8 and 10 because that won't work.
4, 5, 6. 9, 6 is 15. I got it.
You got it.
Yeah.
1 plus 2 plus 3 plus 4 plus, that's 10, plus 5.
I'll give you a hint. Start with 3.
Oh! Yeah, plus 4 plus 5. That is, that's 7, plus 5 is 12, plus 6.
Aha! All right,
did
good.
it.
So all that work, just say 18 is not an answer.
There you go. So what you guys are going to do is you got all the way to 18. You've got a few more, and we're going to let you guys work on that while we check this out.
Some of the Earth's most stunning and diverse habitats are found in the darkest depths of the coastal ocean. Clusters of cold water coral and sponges, towers of egg-case spirals, and fluffy mats of methane-eating microbes. These microbes build diverse ecosystems and, despite their size, are responsible for the most thriving habitats in the dark realms of our coastal ocean. Meet the chemosynthetic microbes, tiny single-celled organisms that convert chemicals into energy to grow. As marine life dies and sinks to the seafloor, it gets buried, and as it decomposes, it slowly builds up methane. Over time, this methane gas escapes through fissures and releases into the water column, forming methane seeps, often between 600 and 5,000 feet. At these depths, beyond the sunlit zone of the ocean, chemosynthetic microbes become the architects of life, building rocks for larger organisms to live and hide on, while also feeding some of them. Though similar to hydrothermal vents, these habitats are not hot, earning them the name cold seeps. Recent explorations of our coastal ocean have surprisingly uncovered thousands of cold seeps off the U.S. coast. Methane seeps are crucial to both marine and human life. They are considered essential fish habitat for fisheries management on the United States Pacific coast, and scientists continue to discover abundant commercially harvested fish species living there. Another crucial service is that these gas-loving microbes actually consume methane, keeping this greenhouse gas locked in the seafloor and out of our atmosphere. Future research may uncover novel medicines that these biodiversity hotspots provide. And while these epicenters of diversity occur beyond the sunlit zone of the water column, they are important to all life on the planet, and our exploration of them has changed scientific understanding of our coastal ocean.
What do elkhorn corals, leatherback sea turtles, and Hawaiian monk seals have in common? They are all protected under the U.S. Endangered Species Act. The Endangered Species Act of 1973 is one of the most effective conservation laws in the United States. Using science-based management plans, it has prevented the extinction of 99% of the species it protects. So how does it work? The U.S. Congress put the U.S. Fish and Wildlife Service in charge of land and freshwater species, and NOAA's National Marine Fisheries Service in charge of marine species. These agencies can review the status of a species on their own, or concerned citizens or groups can petition the agencies to list a species. After a thorough review process, a species can be classified as either endangered or threatened if necessary. Endangered means the species is in danger of extinction throughout all or a significant part of its range. Threatened means the species is likely to become endangered in the foreseeable future. If a species is listed as endangered, it is illegal to kill, harass, harm, or capture it without special permission. Threatened species may be given many of the same protections. Once a species is listed, the agency in charge can designate the species' federally protected habitat. They'll also develop a recovery plan to guide government and private efforts to help the species and get it out of danger. Today, the Endangered Species Act protects over 2,140 listed species. The U.S. Fish and Wildlife Service and NOAA continue to develop new technologies and management approaches to ensure the Endangered Species Act remains effective and that endangered species populations can rebound and their habitats can recover. A healthy ocean needs strong and sustainable populations of all marine species, and the Endangered Species Act has gone a long way to keeping it so.
Split it in half.
All right, well, it looks like Maddie's down to her last three numbers.
keep going.
23, you've always been
11.5.
cutting in half the odd number, so that's 11,
Yes.
and then what number?
11.5.
So 11, and then the next number is,
12.
so does 11 plus 12 make 23?
Yes.
So that's gone.
Gone.
Okay. What about 24?
24. Let's see. That would be 12.
Okay.
Let's try lower. 12 plus.
11 is going to be.
Well, you can go 12 plus 13 if you got 25 out of the way now, right?
Ooh.
Oh, that's. Thank you. Thank you.
So the
So
only thing
final
you're looking for is
24.
24, and I'll give you guys a half a
Yes.
minute, see if you can do it.
A half a minute. Okay. Let's see here. Let's try 5.
Okay.
5 plus 6 plus 7. That would be 11. 18 plus 8. 18 plus
26.
8, 26. Too big.
Okay.
So try starting one
We got
under it and
26
see.
out of the way.
So try it. Well, we're only going to 25.
Oh.
So let's, instead of 5, let's start down at 4.
4. 4 plus 5 plus 6 plus 7 maybe.
Okay.
9. 9.
You're good.
9, 15.
So we're going to let you keep working on this one. It's the only one you got to keep going on. But remember, you can use a longer list of numbers. They could be shorter. Did you learn a little something today?
Yes.
Good. Did you have fun while you were doing it today?
Yes.
That's the most important thing right there. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama-Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.